Welcome to lesson 17. Have a go in your own time. As I said in the last lesson, we're starting to not really cover new things, just do repetition of things we've already learned. This first question is not possible. Why? Because, well, Q could be 2 or 5 or 0 or 11. Could be because it just means like 1 times 1 times 1 equals 1. Well, that's true. Or 1 times 1 equals 1. Yeah, well, that's true. So anyway, next question. Have a go in your own time. The answers are a equals 0 and or, because it's two different variables, so it's an and or situation, b equals 1. So let's have a look at this. We're always trying to tidy things up as we go. Remember, we're generally trying to tidy up brackets and fractions. And there's fractions? Whoa. There's brackets here, so let's get rid of them. They would seem to be in the way. A minus AB minus B squared. Whoa, mine plus B squared minus B squared equals 0. Okay, so make sure you don't make the mistake I nearly made. That one there is a minus B times a minus B, which makes plus B. So we've got a plus B and a minus B. They just cancel. Plus B squared and a minus B squared. They just cancel, which leaves us with A minus AB equals 0. We've got two different objects. We've got an A and we've got a B, and only one equation. So in theory, we can't solve it unless by any chance we can use that trick, the trick where you factorize. Oh wait, that's going to work here, so I'll take the A out. 1 minus B equals 0. Drop a line down, A equals 0. And or, this means and or because remember A and B can both simultaneously be 0. 1 minus B equals 0. I'm going to add B to both sides. That gives me 1 equals B. Switch it around, end up with B equals 1. Next question. Have a go in your own time. The answer is Q equals 4, and you might say for completeness, P is unknown. I don't know. I'd say something like that. We could say it's not possible, something like that. Again, just to be really clear, I'm going to put a plus in front of that. I'm going to put a circle around each object. We've got a bunch of objects added and minus together. Oh, look, we've got a plus P and a minus P. They cancel, leaving us with two Q's and then an 8 on this side. Divide both sides by 4. Not 4. Let me try again. Divide both sides by 2. That gives us Q equals 4. Next question. Have a go in your own time. The answer is m equals 5. I'm going to show you my kind of creative, my kind of the approach we've been using so far, and then I'm going to show you a kind of brute force approach. So my creative approach would be to say, I've got three fractions. I wonder if we can make them look the same. Well, actually, I'm not going to do that. I'm going to do by inspection instead. I'm going to say that I've got something plus 1/15 plus 4/15 equals 4/15. So this something here must be 3/15. Bingo. So we know that 3/15 equals 1 over m. How can we do this? Well, we need to make them look the same. So what if we times the top and the bottom of this fraction by 3? So we've got 3 over 15 equals 3 over 3m. Aha! So that means by inspection, these two must be the same. So 3m equals 15, divide by 3, m equals 5. However, that's a bit fiddly. So to be honest, I'm not sure that's the best way. I wonder I don't know. I wonder if the best way approach here is, let's say minus 1/15 from both sides, which gives us 1 over m equals 3 over 15. Then we could times both sides by m, which gives us 1 equals 3m over 15. And then we could times both sides by 15, which gives us 15 equals 3m. And then basically we're going to end up at m equals 3. The next question is called write as one fraction. There's going to be more than one. Actually, no, there's not more than one. There's just one. As in, there's just one question. Okay, there it is. Have a go in your own time. Now, the answer is 6q plus 1 divided by 6q squared. This is easy if you just follow the basics. And by the way, there is a bonus lesson on this topic. So you can do some more practice. And obviously with anything, you can always, search Google, look on YouTube, look in my ebook, find other teachers, whatever, to get more practice. But specifically, there is a bonus lesson on this. Anyway, I'm going to get on with this. I've got 3 things. I've been told to write it as one fraction, which basically means simplifies as one fraction. So I just need to start combining things. Do we do the plus or the times first? We of course do the times first because of BIDMAS, the order of operations. And how do we multiply fractions? Well, that's easy. We just times the top and the bottoms. So we're going to have 1 over q plus 1 times 1 is 1, 2q times 3q makes 6q squared. Okay? Looking good so far. That's like adding elephants and giraffes. We need them to be exactly the same thing. So this one on the left, I'm going to times the top by, I'm times the bottom by 6q, and therefore I must times the top by the same. So I end up with 6q over 6q squared plus 1 over 6q squared. The bottoms are now the same, which means I can now combine them, if I can write, to be 6q plus 1 divided by 6q squared. There we go. Let's do another solve. Have a go in your own time. Not possible, because there are 2 variables and only one equation. You might have done something like minus q and said, well, p equals 11 minus q. Because you might have said, well, at least we can write one in terms of the other. That's progress, but ultimately we cannot actually solve them, depending on your definition of solve. Let's do a simplify if possible. Have a go in your own time. The answer is 1 over root 5. You may have given your answer as equals root 5 over 5. If you did, well done. Maybe that's in the context of your other learning because you've learned that's a better way of giving the answer. That's great, but in this series of 20 lessons, I'm perfectly happy with 1 over root 5. That's kind of what we're aiming for. In case you're not sure why, what's the square root of 1? Well, it's just 1, so we can just ignore that. And then if you times and then divide by something, they cancel out. Times and divide by something, they effectively cancel out. Times and divide by something, they cancel out. And remember, whenever we're cancelling on a divide, we always leave a 1 behind. Because of this thing where, do you remember, what's 5 minus 5? It's 0. What's 5 divided by 5? It's 1. Because whenever you're dividing, they cancel to leave 1. Whenever you're minusing, they cancel to leave 0. Let's do the next question. This is a calculate. There's a few. I'll let you know when I've written them all down. There we go, that's all of them. Have a go in your own time. I'm going to go from the bottom up. The first one is minus, the second one is 1, and this one is, I'm just going to have to do it 2 times 2 times 2 times 2 times 2 times 2 times 2. So that makes 4, 8, 16, 32, 64, 128. There you go, so the answer is 128. Notice how careful I was there. I don't know any shortcut. I just always do it. This one here, it's it's obviously 1 times 1 times 1 times 1 times 1 times 1 times 1. Well, how many times you multiply 1 by 1, you still just got 1, because we all agree that 1 times 1 is 1, yeah? And 1 times 1 times 1 is 1. So however many times you do it, you still just end up with 1. And this last thing here, I've done it just to emphasize the role of a minus sign. What's minus 1 times minus 1? It's 1. What's minus 2 times minus 3? It's 6, because the minuses cancel. What's minus 1 times minus 1 times minus 1? Well, those cancel to give 1, and then you're left with a minus. So if there's 7 of them, that you've got a minus times a minus times a minus times or 7 times, and you end up with with pairs of them cancelling off, but you have a minus left behind. So to make that clearer, I might put a 1 there, and then that's minus 1. So minus 1 to the 7 is minus 1. Calculate. Just systematically do what you can see and it will be fine. Try and shortcut, you might have issues. The answer is 2. If you got this wrong, it could be for many reasons, but it might be because you're rushing a bit. It might be because you're not just... Please just do the basics well. I'm going to look at this. Right, there's a minus. That means flip. Let's just do that straight away. So that gives me 8 over 1. And then the third still sits there. I haven't done that yet. It just sits there. Notice I'm just doing the basics. I'm not trying to be clever. I'm just picking something. I'm doing it carefully. That's just 8 to the third, yeah, because the over 1 is doesn't matter in this case. It's a whole number. What does the third mean? The number is on the bottom, so it's a root. So that must mean cubed root or third root, which means that's just going to be the cubed root of 8, which is 2. So just carefully going through to get the right answer. Let's do another true or false. You'll notice I tend to use true or false on this particular topic, and it's because I find it's quite an effective way of learning this topic. Have a go in your own time. True or false? And the answers are true, 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 false. Obviously skip to the next question if you're happy. But if you got it wrong, let's just talk it through. We know this is true. This is like the fundamental law that we learn. And maybe you remember we did this before. If number 1 is true, number 2 must be true as well, because if you just keep adding extra ones on the list, they basically just add in as well. And then with the P and the Q, it's just the same letter. It's just different letters, same thing. And then with the 2 and the 3, it's just numbers instead of letters, and 2 times 3 makes 6. Now, this is the important one down here. If you thought this was correct, I'm a little bit well, it depends on why you did it. Who knows? Could be any number of reasons. But in general, a little bit disappointed, because let's concentrate on the basics. And the basics are that the rule is square root of a square root of b equals square root of ab. To check if it's true, we could have done something like said, okay, what's the square root of 7 times the square root of 2? Well, that'd be the square root of 7 times 2, which would be the square root of 14. Okay, so then I've shown that that isn't true. Next question. Okay, this next question is weird. But we've learnt a load of stuff, and if you just stick to what we've learnt and just do it systematically, don't try and be clever, just steadily do one thing at a time, there's a reasonable chance that you can work this out. And if you can't, then hopefully the answer will give you some insight and help you do it, deepen your understanding of the subject. So have a go. So the answer is x equals 3 or minus 3. Now let's look at how we get there. Given this, solve this. Wait a sec. Wait a sec. We don't need those words, do we? Who cares? Well, we kind of need solve. We kind of need solve. We don't need given. So just saying solve, and there's two equations. What if we had the equation, we've had it before, haven't we? We had like a plus b equals 7, and then a equals 5. And then it's like, oh, well, if I know what a is, I could just stick it in there. Well, look at this. We've got f of x and f of x. They're the same thing. I mean, they look a bit weird, but whatever, they're the same thing. So that just must mean that x squared equals 9. Yeah, because you've got an equation here, f of x equals x squared, f of x equals 9. So obviously x squared is equal to 9, because they're the same thing. So now, there's two ways of solving this. You can either just square root both sides, which gives you x equals 3 or minus 3, because remember, a root can be plus or minus. Or, a better way of answering it, in my opinion, in many mathematicians' opinion, is that we minus 9 from both sides, which leads us to have x squared minus 9 equals 0, and then we factorize. You may have learnt to do it like this. I'm just showing you in case you've learned this before, and I just want to reinforce that technically you could say that this is a better way of doing it. I don't know. I always think it's better. But did I just do this wrong? I meant to put a plus there. That was largely an aside. We haven't really covered this issue in these classes, so I just wanted to touch on it briefly in case it was something you were aware of. But basically, blah blah blah. Oh look, when it's functions, because remember this is the functions topic, we can still do all the other things we know as well with the equations and stuff. Here's the solve. Have a go in your own time. Not possible. X squared is a thing, y is a thing. They are two different things, and there's only one equation. I can't see any way of factorizing that to use the trick, so there's nothing we can do. Have a go at this. Can you solve this one? Not possible. Why is that? Because there's no equal sign. Look, there's no equal sign. That's why you can't do it. You might have tried to solve that, but there's no equal sign, so you can't do it. Next question. Plot, but let's say sketch because we're lazy. Have a go in your own time. I'm just going to set up some axes so I can draw my answer. Right, so the answer looks like this. I'm now going to talk through how I did it. I'm going to look at this and I'm going to say this is messy. It needs tidying up. Why does it need tidying up? Because we want the equation to be y equals, then we can draw a graph of it. So I'm going to add 3 to both sides. Remember we've talked about this before, this idea that in maths we have things that are messy, we have to tidy them up before we can then do things we want. Okay, we could draw a table of x and y, and for example if x is 0, y is 3, plot it. If x is 1, y is 4. If x is minus 1, y is 4, blah blah blah. Or, and that's a great way. Or you might just know, oh well I know what it looks like because, maybe you might use this as an explanation. You might say, well, it's like the graph's y equals x squared, but notice the y has 3 added to it, which means that every value of y is 3 higher. So it's been effectively, the graph has been raised by 3. There we go. Next question. Plot, but let's sketch because we're lazy. Remember, if it says plot or draw, you've got to be aware that you might have to do it neatly, but we're just sketching so we can just do it rough. But we still want to see the axes, we still want to see them labelled, we still want to see an arrow because we need to know which direction positive is, and we still need to know what the origin is, what the value of the origin is. I'm just going to stick an extra one here as well. I don't know where to put it, I've kind of run out of space. I wonder if I can make some space here. We can just about do this, here we go. There we go, we've got 4 to do. I'm just going to set up axes for all 4. And my answers are y equals x, y equals 3, going to mark that as 3, x equals 2, mark that as 2, y equals x plus 3, mark that as 3. Skip to the next question if you're happy, obviously. I think we know this one by now. For every value of x, the value of y is the same. Value of x, the value of y is the same, because the rule is saying y is the same as x. Here, note that each value of x, each x value is different, so it's obviously not x equals, it must be y equals. Here, notice that every value of y is different, and therefore it must be x equals. And then for the final one, it's like the graph y equals x, but y has had 3 added to it every single time, which means effectively the whole line is raised by 3. Factorize question next. Have a go in your own time. And e to the x, what does that mean? Who cares? Doesn't matter. We haven't been asked. We've just been asked to factorize it. We could take out an x as well, couldn't we? So let's say x e to the x. That should have been 10x. So remember the stage process. The first thing is we're trying to take things out, and we do it repeatedly. We've done that twice. I can't see any more, so we now move on to the second step, which is to try and do double brackets. So equals x e to the x. I'm going to try and do double brackets. That's going to have to be an x and an x to make the x squared. There's going to be a plus and a plus. Well, how do we make 9? Well, there's 1 times, well, it's 1 times 9. I'm pretty sure. Multiply it out if you're not sure. And when I say multiply out, you could just multiply out this bit on its own. Do you know what? I'm just going to quickly do it now just to show you. That's x squared. That's plus 9x. That's plus x. That's plus 9, which makes x squared plus 10x plus 9. Bingo, that was what we wanted, but remember the final answer was this one there. Let's do the next question. Got to simplify question next. There's 3 of them. There's 4 of them. I'm going to write them out. I'll tell you when I've finished. Have a go in your own time. And the answer is 2x cubed, x to the 6, 1, and 0. So the last two, we're kind of getting the hang of. This is always 1 and 0, isn't it? It's just that's a 0. Skip forward if you want. What's going on with the first one? Well, there's two things that are exactly the same. So that means there's 2 of them. Oh, so there's 2x cubed. The next one is x times x times x, because that's x cubed, times x times x times x, because that's x cubed. Oh, and x times x times x times x times x times x. There's 6 of them, so it's x to the 6. Ta-da! And remember, anything divided by itself is just equal to 1. And if you take something and then minus there's nothing left. Last question is a calculate. I'll let you know when I've written them all down. And the answers are 25, 16, 100, x, and 3.2. That's the end of the video. I'm just going to talk this through in case you want a bit more help. Let's take the first one. Effectively, the first one is 5 times 5. Oh, which is 25. Oh, I guess it's no coincidence that it's the same as the number inside. Square root of 16 is 4. Square root of 16 is 4. 4 times 4 is 16. Oh, look. Oh, it's just the number inside. Square root of 100 is 10. Square root of 100 is 10. 10 times 10 is 10. Oh, it's the number that's inside. Oh, see, I guess that's no coincidence. And it isn't a coincidence, so that's how it works. So therefore, square root of x times square root of x is x. Square root of 3.2 times square root of 3.2. Square root of kyp times square root of kyp would be kyp. The square root of 11.81 times the square root of 11.81 would be the square root of 11.8. Would be, whoops, 11.81. So the pattern continues. See you in the next video.